Okay, so good afternoon again. Solve natin ulit yung problem set number 7. Okay? Solve natin siya ulit. So yung problem set number 7, may dalawa siyang problem. So that would be problems 10.18. Okay? So 10.18, meron ka daw inductor current na amperes. And then your circuit looks like this. Okay. Yung circuit natin, ganito. Tapos, gusto na natin malaman yung VR and then VL. Okay? Okay. Para lang malinaw sa lahat, kapag nag-designate na ng ganito na plus and minus yung VL, na-assume mo na rin na yung IL ay pa ganito. Okay? From plus to minus. Okay. Okay. So, sa mga problem na ganito, sa first and second order transients, the usual way of solving things, usual, is that, number one, is that, kunin mo yung Thevenin or Norton. Pero kung sadali yung Thevenin, no? Circuit. Differential equation. May differential equation ka na. You solve for that differential equation. So you have your homogeneous. Tapos, particular. Tapos ka na, di ba? Tapos ka na. Okay? Lagyan natin ng 5. Other solutions. So, kasi yung mga solutions mo sa 3 and 4 would be yung state variables. Kuwari, sa inductors, ang makukuha mo would be IL. Di ba? So, to get VL, kunin mo yung derivative ng IL, tapos multiply mo ng L. Okay? Kasi di ba, VL is equal to LDI dt. So, ayun yung mga other solution. Tapos, for this case, VR mo, makuha mo siya by multiplying IL times R. So, that's another solution. Okay? Pero ang mahalaga is that sa number 4, tapos ka na dun sa hard part ng solving. Okay, so let's do this. So, number 1, gawin natin. Number 1. Let's solve for that Thevenin. Okay, so solving for RTH is so turn off mo lahat ng source, no? Turn off all sources. Turn off all sources. And then, drawing ulit natin yung circuit para hindi tayo mahirapan. Yung circuit. 2R dito. Madi-disconnect yung magiging open circuit yung current source. Tapos, another one here. And then, okay. Yung terminals natin nandito. Tatanggalin natin inductor, syempre. Ganyan itsura niya, di ba? Okay, pero simplify ko yung buhay ko by redrawing this thing in a more familiar manner. Diba? Same lang din yan. Mas madali lang siya maintindihan pag ganito. Okay? Then I get the total resistance of this circuit. Okay? So, wala nang silbi tong putol dito, syempre. Tapos, itong dalawang 2R, they are in parallel with each other. So, parehas sila ng head, di ba? Dito, ito yung point ng head nila. Yung tail nila parehas din. So, they are parallel. So, RTH is equal to 2R parallel with 2R. Okay? And those two resistors are in series with R. Okay? So, plus R. Okay, yung parallel with itself, no? Yung parallel with, kalahati lang yung magiging kalalabasan nun. Okay? So, this is R plus R. That's 2R. Okay? So, we have our RTH to be 2R. Okay? Tapos, buksan ko ngayon by superposition lang, buksan ko muna si VS. Okay? Para makuha ko yung first part ng VTH ko. Okay? Okay. Ni-discuss natin ngayon to kasi baka pag in-ano ko lang siya, sinave ko lang as ni-record ko lang siya on my own time. Baka hindi nyo buksan eh. Okay. So, yan. Now, I would, titingnan ko ngayon kung ano yung voltage in these terminals. Okay? These terminals, titingnan ko yung voltage. Alright. So, pag titingnan ko yung voltage dito, ibig sabihin, walang nag-flow dyan, di ba? Putol tong circuit na to. So, wala din dapat dumadaloy dito sa R mo. Okay? Okay. So, voltage divider lang ito. Voltage divider lang. VTH 1. So, this is easy, no, na voltage divider kasi parehas. So, pag parehas, dapat kalahati lang. Pero kung di kayo naniniwala, gawin natin slowly. Numerator, yung ito. Tapos denominator would be the sum of those two. Okay? Evidently, this is just Vs over 2. Okay? Turn on IS. So, babatayin natin ulit si voltage source. Then, I would have to reattach yung current source natin, which is IS. Okay. So, marami nagkakamali dito. Iniisip nila, dito lang dadalo yung dito lang dadalo yung IS. Pero mali yun. Okay. So, may share yung 2R dito, may share siya nung current dito, yung current source. Meron din, itong 2R dito, meron din siyang share ng current source. Okay? You can simplify this further as something like this. Tapos isang resistor na lang. So, yung resistor would be 2R parallel with 2R. Tama? Okay? And that's simply R. Tapos yung voltage dito would be simply IS times R. Okay? So that VTH2 is just IS times R. Okay? Another way of solving this is that tingnan mo yung ano, di ba IS, magbibigay siya ng share to both resistors. Okay? Now, pansinin mo yung resistors, parehas lang yung value nila. So, dapat walang bias, walang preference si IS. So, bibigyan niya ng tigkalahati si 2R tsaka si 2R. Bibigyan niya ng kalahati yung dalawang ano. Okay? So, at this point, yung voltage dito, siyempre kung ano lang yung current na dumaan sa kanya, so which is kalahati ng IS, tapos yung resistance, which is 2R. Okay? So, same lang makuha mo. Okay, then we have our VTH to be Vs over 2, sum lang ng dalawa, plus ISR. Okay? Okay. So, this is the usual way. Ito na yung circuit natin, VTH. Huwag nyo na isulat yung RTH saka VTH. Nasulat nyo naman na yung yung mga bagay-bagay. Okay? So, okay na yung RTH saka VTH para hindi masyadong magulo yung circuit. Lalagay nyo na lang na sa tabi na yung VTH ay ganun yung VTH kasi nandito naman siya. Okay? Tapos yung RTH ko would be 2R. Tama, di ba? 2R. 2R. Okay. So, this is now our Thevenin equivalent circuit. Now, you go back to your book. Tapos, tingnan mo yung differential equation na para hindi ka na mag-iisip. Pero, syempre, pwede mo naman kunin yung differential equation by doing KCL. Sabi ko nga, pag wala kang masolve sa mga number, mag-KCL ka o di ka mag-KBL ka. Okay? Lilinaw yung buhay mo pag ganun. Yung makikita kang equations, pwede ko magsamahin itong mga to. Okay? Okay. So, the differential equation governing this circuit is LDIL over dt plus IL RTH, whatever RTH is, and then equal to VTH. Okay? Okay. So, yung IL natin, alam na natin si IL magiging IL homogeneous plus IL particular. Okay? So, we now have to solve for those two. Okay. So, for the homogeneous part, homogeneous. Okay? Yung ILH dito, na-solve na sa libro, it's this. Okay? A is a constant. Masasolve mo siya pag ginamit mo na initial conditions. RTH over L. Okay? And T. Okay? So, this is the homogeneous part. Ibig sabihin, zero out mo to, tapos you solve for the differential equation. But then again, nasa libro nyo na yung solution niyan, which is this part. Okay? Okay. So, now we go to the particular solution, which is plug in na natin yung VTH. So, yung VTH natin, recall that VTH is Vs over 2 plus ISR. Okay? And kung ipa-plug in natin yung Vs and Is, yung Vs and Is natin dito would be yung ramps, dalawang ramp. So, Vs. So, may slope na K1. Tapos, yung Is, may slope na kuwari magkaiba sila yun, K2. Okay? So, of course, with respect to time. Okay, so this is given. This is given. Hindi ko lang nasulat, syempre. Okay, so plugging things in, yung VS natin would be, so this is the usual way, no? Ito yung nasa libro. Nothing new, nothing new. Nagawa lang natin siya para makita nyo na slow and steady wins the race. Okay? Ito yung pinaka-safest. Pinaka-safest pa. This is the safest way of doing things. So, ayusin ko lang. Diba pwede kong ganito to. Okay? So, this is my VTH. Okay? And then, from your book, punta ka sa libro, yung ansatz mo, or yung guess mo, yung for your particular solution, it's actually a linear one. So hindi lang yun term with term that is a function of t, pero magdadagdag ka pa raw. So bt plus t. Okay? Hindi natin magamit yung a kasi nagamit na natin yung a kanina. Tapos yung c naman baka makaisipin natin capacitor. So bt plus d. Okay, so ito yung guess natin, no? Kasi pa-plug in mo siya ngayon dun sa differential equation mo, which is LDIL plus IL RTH. Guys, pag di nyo pa ito nakuha sa finals, gantong-ganto na ibibigay ko sa finals. So, magbabago lang yung mga voltages. Siyempre, may lalabas doon na first order transient. Okay, then on the right-hand side is VTH. Okay, so this is our equation, working equation. Plug in natin yung mga bagay-bagay natin. So, yung ILP and then yung VTH. Okay, so L, derivative. This is dt plus d. Okay? Nothing new. dt plus d. RTH. And then this must be equal to K1 over 2 plus K2R times T. Okay? Okay. Okay, derivative nito would just be letter B. And then, sa kabila naman, distribute natin yung RTH plus DRTH. Okay? And then, as is, wala namang bago. Okay. So, you have this. Okay? Now, madali na lang to i-solve kasi i-match mo lang, no? Eyeballin mo lang to. So, yung may T, sila dapat yung equal. So, BRTH T, okay, must be equal to whatever terms na may T rin. Siyempre. Diba? And then the other ones, LB plus DRTH must be equal to 0. Okay? 0. Okay. So, itong unang equation natin dito, madali ito ma-solve kasi ma-isolate mo si B kasi given ka naman ng RTH. Okay? Tapos ma-solve mo na ito nandito sa baba. Using the value of B. Okay, so cancel na natin si agad si T. Okay. Okay. So now we just have B to be equal to K1 over 2 times RTH. Okay? Divide mo siya by both sides by RTH, di ba? So yung RTH natin ay 2R. So ito ay magiging 4R plus K2 R divided by 2R. So R cancels out. So K2 over 2 na lang. Okay, so that's your B. And then yung D naman, masolve natin siya by this one. So DRTH, rekta na natin, kaya nyo na yan. D must be equal to negative L B over RTH. Okay? LB over RTH. So this is negative L over 2R. Tapos K1 4R plus K2 over 2. Okay? Okay. Wala pa namang malabo, di ba? So pinlagin lang natin si B dito. Kasi RTH ay 2R. Alright. Now, tapos ka na. Tapos ka na dun sa hard part ng solving. Sa bulk ng solving. Okay, so I have IL, the total response. That would be A, e raised to negative R, 2R over L. RTH over, ano to, diba? RTH over L to. So, plug in na natin sa RTH. Okay? Double check lang natin. Okay, RTH over L. So, yung RTH natin ay 2R. And then, plus yung BT, plus D natin. Okay? Pero plug in na rin natin, parang tayo mahirapan. Likely lang naman. Sometimes kasi mas madali siyang i-plug in kaysa iwanan mo as variables. And in this case, mas madali siya pag pinlog in mo. Okay, paano ko nalaman? Experience. K2 over 2. This is T. Plus yung D natin, which is minus K over 2R. K1 4R plus K2 over 2. Okay? Okay. So, makikita mo ka dito, pwede may factor out tong dalawang bagay natin. Pero wag na natin gawin yun. Okay. Next thing, alam natin that is IL of 0. 10 raised to negative 3. Okay. So we have to solve for A naman. So pa-plug-in mo lang yung values ng T is equal to 0. Maglalaho yung iba't ibang terms dyan. So you can see that A, E raised to 0 is 1. Tapos mawawala yung second term. Kasi T is equal to 0 and then matitira to. K1 over 4R minus K2 over 2. Okay. Now, evidently, apparently, this is easy. Plus L over 2R, K1 over 4R, minus K2 over 2. Okay? Okay, now let's plug that in there. So IL of T is 10 raised to negative 3, E raised to negative T over R, over RC tuloy. Negative 2R over L times T. Okay? So, pinlog in ko to doon. Plus L over 2R. K1 4R minus K2 over 2 E raised to negative 2R over L. So, kinocombine lang natin yung mga sagot, no? Wala tayong bagong sinasolve. Pina-plug in lang natin. Okay? Pina-plug in lang natin yung mga bagay-bagay. So, let's get these two terms here. So, lagay ko sa ilalim na lang. Plus K1 over 4r plus then minus k2 okay, may mali ako. Plus to dapat. Tama. Plus to. Plus to. Okay, kasi ito yun. Taka ko weird na itsura ng equations. Okay, anyway, going back. Copying ko to. K1 over 4r plus K2 over 2 T. Tapos, this one, minus L over 2r K1 over 4r plus K2 over 2. Okay, so yan. Okay, nice, di ba? Pwede pa natin to simplify. Mapansin mo, ito. Pansin mo ito. Pwede kong ayusin, no? Pwede kong ayusin. Itong may E dito tapos may 1 dito, di ba? So, 10 raised to negative 3. As is lang to, 2r over L. Tapos, minus L over 2r. K1 over 4r plus K2 over 2. Nagiging 1. So, ito yung 1 kasi pinactor out ko siya. Tapos, minus this part. Okay? Kasi negative yung pinactor out ko. So, e raised to negative 2r t over L. Okay? Nice. Okay? Kaya ako siya pinactor out kasi maganda itsura nito. Tapos, I just have to plug in the linear term, which is K1 4r plus K2 over 2. Okay, so this is my IL of T. VL, mas madali. Madali na VL kasi L DIL of dt. So that is taking the derivative of these things. Okay, so L tapos 10 2r t over L. Tapos the derivative to, di ba? Kasi sabi dito. So may extra factor ako na negative 2r over L. Tama? Okay. And then for here, I have L squared 2r K1 over 4r plus K2 over 2. And then derivative nito, which is just 2r over L e raised to negative 2r over L. Okay? So, yung negative sign nag-cancel. Tapos yung 1, syempre, mag-vanish lang siya. And then, lastly, plus yung sa baba, which is this. So, L K1 over 4r, K2 over 2, mawala na yung T. Okay? Okay. Okay, so simplify lang natin para it looks nice. So, L cancels out in the first term, tapos may negative 2r ka. May negative 2r times 10 raised to negative 3, e raised to negative 2r, t over L. And then, 2r cancels out. L, yung isang L magka-cancel. And kung mapapansin nyo, L times this part, yun yung matitira. And this one has L times that part. matitira. So, let's have it nicely. Pinactor out ko itong factor na to. So, this one is 1. Tapos, this part is minus e raised to. Okay? So, this is the answer for VL of t. Okay? And then, lastly, VR of t would be IL times R. Okay? So, ayan na siya. Multiply nyo lang ng R. Hindi natin siya sulat. Okay? So, magkakaroon na ng R. Maka-cancel to. Okay. So, yan. VR is just IL T times R. Okay, now you've solved for everything. Okay, so that's the usual way. Let's try yung state method, pero baka maguluhan kayo, pero let's try it. Okay, so the state method, ganun pa rin naman. Thevenin, muna ka sa Thevenin. Number 2, obtain yung time constant. Depending dun sa Thevenin equivalent circuit. Okay? Now, and then number 3 would be ZIR. Number 4, ZSR. 5, again, the other solutions. Okay. So let's do this. So number 1 is, okay na. Solve na natin. RTH would be equal to 2R. VTH is equal to VS over 2 plus ISR. Okay? Number 2. Obtain time constant. The time constant is tau, which is L over RTH, and that is L over 2R. Okay? Para pag nagkaroon ka ng mga exponential mamaya, magiging e raised to negative t over tau, which is equal to e raised to negative 2R over L times t. Okay? K. Gets naman yung bakit nanging ganun, di ba? Kasi nasa denominator itong fraction na to. Tapos, pag nandyan siya, mag-flip over siya sa kabila. For inductors lang po yung L over RTH. Yes. Kasi yun lang yung may L. Siyempre, itong time constant nanggaling to dun sa Nanggaling to dun sa itsura nung Thevenin circuit natin. Okay, may, na yun, nag-skip na ako nung So, nandito siya nanggaling. Tapos, mayroon siyang differential equation. Okay. Tapos, ilalabas na time constant dito would be yung L over RTH. Okay? Hindi siya, well, kung ganito yung circuit mo lagi, so L over RTH siya. Okay, pero pag naging parallel na, baka things might differ. As current source, okay, so that's different things. Okay, shows, nandito lagi. Nag-shortcut ka to tayo kasi na-solve na natin tong number 1, and then alam naman natin na series RL lang yun. Tapos, ito yung lalabas na time constant sa kanya. Okay? Okay. So now we go to Number 3 would be ZIR. Okay? ZIR. Okay. When you're given ay tawag dito. Kapag binigyan ka ng voltage or na-simplify mo yung circuit para maging voltage source na lang siya. Okay, na-simplify na natin yung mga bagay-bagay, diba? Na naging voltage source na lang siya. Okay? Preferred natin na mag-work on sa voltages. Okay? Siyempre, kung ginawa natin tong Norton, gusto natin mag-work on tayo sa current naman. Okay. So, anong point ko? So, you want all the answers here to be voltages. Okay, so sa ZIR, ito yung mga i-discharge mo yung stored energies. Okay? So, you want to discharge the stored energies. Ibig sabihin, kung meron kang initial condition, this is the time to shine. Okay? Dito mo siya makikita. So, we are given an initial condition of IL of 0, 10 raised to negative 3 amperes. Okay? So, sabi nga natin, gusto natin mag-work on sa voltages. So, ililipat natin to sa voltage. Okay? Okay. Pero, the idea is, kailangan mo discharge yung stored energy. So, alam natin, this would give me the IL of t to become, lagyan natin ng 1, no? Kasi part 1 lang naman siya. Part 1 of many. E raised to negative t over tau. Okay? So, discharging ito. Okay? But, ayaw natin ng inductors, ayaw natin ng current, so lilipat natin siya sa voltage. So, VL, 1, T is equal to L, VIL, 1 over dt. And this is fairly simple. Okay, gets? Derivative ng exponential, bababa yung mga factors dito. So, negative tau, bababa. Okay, tas may L na factor dahil VL is equal to this part. Okay? Okay. So, yung ZIR, lagi siyang mag-ano, no? Lagi siyang galing dun sa state variables. Okay? So, ayun kasi ini-store nila. For the capacitors, voltage yung ini-store nila. So, yung voltage yung gagamitan mo netong formula, itong framework. Okay. Now, tapos tayo sa ZIR, ayun lang yung ganap sa kanya. So, ZSR naman, kailangan mong gawin is to dissipate energy supplied at every time, every t. Okay? Okay. So, gusto natin, dissipate natin energy supplied at every time t. Ngayon, meron tayong mga supply na usual supply would be step. Okay? And yung ramp. Sa case natin ngayon, ramp, pero lagay na rin natin yung step. So, yung step, magiging as is lang siya. As is. I-explain ko mamaya kung ano ibig sabihin ko nito. Tapos, ito ay integrate to slope. The slope. Okay? Okay. Now, ano ibig sabihin natin ng dissipate energy supplied at every time t? So, yung ZSR solutions mo would be PL2 would look like something like this. Would look something like this. Okay? Yan. Kapag okay. So, kapag step, as is lang siya, ganito itsura niya. Kapag ramp, i-integrate mo the slope. Okay? So, nandito yung slope ng bagay mo. Okay, so let's do this. Mas madali siguro pag nakita natin the example. Okay, so sa VL2 natin, ang mangyayari is that ramps yung ano natin, no? Ramp yung both na input natin. So, VL2 natin would look like this. So, integrate the slope. Okay? Ito yung slope ng VTH, di ba? Tapos integrate mo siya. Ginawa ko lang T prime para hindi magulo yung integral. Tapos integrate mo from 0 to T. Okay, 0 to T kasi 0 nag-start yung VTH natin. Okay? So, this is 0, T. Tapos, yung slope ng VTH natin would be, tatanggalin mo lang yung T, syempre. Yung derivative mo lang siya with respect to T. Okay? So, di ba dapat may T dito, tapos din derivative natin. Okay? So, yan yun. E raised to negative T prime with tau, then dt prime. Okay? Okay, and this is a fairly straightforward integral. Factor out lang, then I have negative tau. Factor out natin negative tau. Yung constant na lalabas sa integral, no? So I have e raised to negative t prime over tau evaluated from 0 to t. Okay, and this is equal to k1, k2, okay, and then this is minus 1. Okay? And then, pasok ko si negative sign para cute. Tapos, i-expand ko na tong si tau as L over 2R. So, I have K1L over 4R plus K2L over 2. Okay? Kasi magka-cancel out yung R. And then I have 1 minus e raised to negative t over tau. Okay. So, nakuha natin na ito yung VL2. And kung mapansin mo, yung total VL, na-solve na natin. So, VL is just VL1 plus VL2. Okay, tingnan natin kung tama ba. Ito yung VL2. Okay, alalahanin. Tapos, VL1 ay ito, which is negative 2R times 10 to the negative 3 e raised to negative t over tau. Okay, so ayun ba yung nakuha natin kanina? Okay, negative 2R e raised to something. Okay, correct. Tapos ito, then yung 1 minus exponential. So, tama yung nakuha natin. Okay. So, bakit ganito yung bakit ganito itsura ng ramp? So, may nagtanong no, bakit integrate the slope? So, yung kasi, yung ramp, let's draw a ramp here. So, may ramp na, diba? Okay? So, pwede mong i-zoom in yan, tapos makikita mo na marami siyang step input. Step input lang din siya. Puro steps input siya, step input. Okay? Okay. And so, poproduce ka ng infinitesimal infinitesimal ramps. So, yung maliit na ramps na yun, ayun yung slope. Tapos, kailangan mo siyang buuin, di ba? Kailangan mo isum lahat ng ramps. Ay, kailangan mo isum lahat ng step inputs dito. So, kaya mo siya ini-integrate. Okay? Ayun yung ano sa kanya. Pero, again, sabi ko sa inyo, slow and steady wins the race. Mas sure yung kabila. Para, ito kasi prescribed yung ginagawa. Prescribed yung ginagawa. Tapos, ayan, ramp and step siya. So, kung hindi na ramp and step, baka malito kayo. Okay? So, ayan. Solve na natin si VLN. Okay, try natin yung kabilang problem. Yung kabilang problem is yung capacitor naman para a problem. Problem 10.27. Okay. So, nakuha natin VL dito, di ba? Tapos, para makuha yung VR, syempre mag-ano na lang kayo, KVL na lang. Okay? Another ways. No? Okay. Yung madaling way para ma-solve yung VR from here, kung ito yung gagamitin mong way of solving things, is that pupunta ka sa ang gagawin mo naman is babalik ka sa original circuit mo, then i-detach mo tong dalawang to. I-detach mo tong dalawang to. Tapos kunin mo yung Thevenin nito. Okay? Kunin mo yung Thevenin nitong lalabas dito. Tapos, from that, mag-solve mo na yung VR. Okay? Okay. Let's go back. Let's go try problem 10.27. Hindi ko alam yung problem. Okay. So, the problem is for 10.27, ito yung mas mahirap ata. Meron ka VI, and then you have your capacitor. Tapos, you have a resistor here, R. Tapos gusto mo malaman si VR. Tapos you have C, capacitor. And then, okay. Tapos, ang problema dito is yung VI. Kasi yung VI, yung tsura niya ganito. Okay, so, K1. Tapos tatalon siya to K2. Tapos magra-ramp siya with the slope of K3. Okay? Okay. So, let's do the usual way. Tapos, try natin yung shortcut. Okay, so let's do number 1. Number 1 would be getting the Thevenin equivalent circuit, which is no need. Diba? No need. Kasi nakasimplify na. No need. KVL will do. So, KVL ka, masolve mo tong dito. Makukuha mo na yung differential equation. Okay, so number 2 would be the differential equation. So that is dVc over dt plus Vc over Rc, and then equal siya sa Vi over Rc. Okay? And then, of course, as usual, VC would become two terms, CH plus VCP. Okay. Number 3. So yung homogeneous part, andali ito kasi nasa libro na. A constant, A. Okay, so si A, malalaman natin siya mamaya pag nalagay na natin yung initial conditions. Then next would be particular. Okay, now, ang kailangang problemahin dito is ano yung form ng VI. Ano yung equation ng VI. Okay? Okay. So, ang ano dito, ang assumption dito sa libro niya, sa problem na to is that yung si K1, matagal na siyang sinusupply, no? Galing pa siya negative infinity. K1. Matagal na siyang sinupply patungo sa capacitor mo. Okay? So, si capacitor mo, full charge na siya. So, pagdating ng time is equal to 0, pagdating ng time is equal to 0, merong laman yung capacitor. So, meron siyang initial condition dahil sa dahil sa voltage given sa kanya before time is equal to 0. So, yung problema mo ngayon is yung pagdating ng t is equal to 0, meron kang change na ganito. Okay? So, ang input mo lang talaga is actually K2 plus K3. Okay? Tapos t is greater than 0. So, ito yung mararamdaman mo na parang ito yung nanilagay sa'yo. Tapos, ito kasi yung laman mo na before time is equal to 0. Okay? And then, ito yung ilalagay sa'yo. Okay, no, hindi to hindi itong equation na VI natin, hindi siya dependent sa time is equal to 0. Okay? So, dependent siya kung saan matagal lang charge yung VC. So, kung wari binigyan kayo ng problem na ganito, Okay. So, hindi ibig sabihin nakatutok yung time is equal to 0 dyan. Itong buo na yung initial condition mo. Itong buo na initial condition mo. Hindi. Ang initial condition mo lang dito, manggagaling sa part na to. Okay? Manggagaling sa part na to. Okay? Okay. So, baka mamaya lumabas sa exam eh. So, ito na yung input natin. So, ramp lang ito. And then, you have your ansatz to be BCP. So, ganun lang din. Try pa rin natin yung linear. Tapos, plug in natin sa equation natin, which is derivative, which is B. Rekta na natin para mabilis. Derivative, tapos 1 over RC ng dt plus t. And then, this must be equal to K2 plus K3 t. K2 over RC. Kasi may RC pa. Divided by RC. Plus K2, K3 over RC. Tama ba? Okay, tama. Okay, with this, simplify pa natin ng konti. B plus D over RC. And then plus B over RC. T. Okay, eyeballin mo lang. Yung may mga T, sila mag-equal. So, yung may mga T, sila mag-equal. So, B over RC is equal to K3 over RC. Then, yung mga constant, they must be equal also. B plus D over RC must then be equal to, yun dito, yung constant lang, K2 over RC. Okay? Evidently, alam natin si B to be K3. Cancel yung RC. So, B is equal to K3. And then, Plug in natin itong si B dito sa kabila para ma-solve si D. Okay, so simplify na natin ng konti para mas mabilis. K3 times RC plus D equal to K2. Okay, so nag-multiply lang ako ng RC on all sides para it looks neat. Therefore, D is apparent. K3 minus K3 RC. Okay, now you have your VC. Tapos ka na. Almost na. Katapos. So this is A e raised to negative T over RC plus yung BT D. Okay? So yung BT ko ay K3 T. Okay, wait lang. Okay, tama naman ako. So 4. And then plus yung D mo, which is K2 minus K3 RC. Okay? Okay. So yan. Okay, now we go to VC of 0. Initial condition. So, hanapin mo lang kung ano nakastore sa kanya. So, yung nakastore sa kanya is K1. Nakastore sa kanya is K1. Kasi matagal na siyang charged by K1. Okay, so K1, it must be equal to A, e raised to 0, which is 1. K3 times 0, 0. Plus K2 minus K3 RC. Okay. Alam ko agad na si A. This must be K1 minus K2 plus K3 RC. Okay, and then I have my VC equal to tapos K1 minus K2 e raised to negative T over RC. Pina-plug in lang natin si A dun sa equation natin, walang bago. Plus K3 RC e raised to T over RC plus K3 T plus K2 minus K3 RC. Okay? Okay. So, yan. Okay. So, ito yung VC natin. Ang mahalaga sa atin is yung VR, di ba? VR yung mahalaga sa atin. So, how do we get VR? Yung VR is just IC, the current through the capacitor times yung resistance nung tinitignan natin sa VR. So, this is just R times C dVC over dt. Okay? Okay. So, the derivative lang natin to, RC times the derivative ng CAS. So, this is K1 minus K2 divided by negative RC e raised to negative T RC plus K3 RC over RC times negative e raised to plus K3. Okay? So, wala nang iba kasi constants lang sila. They would vanish sa derivative. Okay? So this one is, pasok ko lang yung negative sign. So this gives me K2 minus K1. RC, here is negative T over RC. And mapansin nyo dito, you can simplify this. Factor out natin si K3. So we have K3 times 1 minus e raised negative T over RC. Oops. Okay, and then, yun na, we're done. K2 minus K1 e raised negative T over RC. Tapos, K3 times 1 K3 RC e raised negative T over RC. Okay? Okay. So this is the solution. Okay. Now let's try the state method. Ito na. Sir, bakit po yung horizontal lang na part yung initial condition doon po sa dinrawing nyo kanina? So may linear part after nung horizontal for t less than 0. Hindi po ba tataas? Since tumaas na po yung VI, hindi po ba tataas na din yung VC? So hindi na lang po yung horizontal part. Ang tanong mo ba as bakit yung initial condition natin hindi K1 plus K2? Or K2 kasi itong buong linya. Ang tanong mo ba bakit walang inclusion yung walang effect yung K2 sa initial condition ng K1? Ay sa initial condition ng voltage sa capacitor? Ay may tanong mo? Ito. Hindi ko magets yung tanong, sorry. Sige, rephrase. Bakit yung itong part na to, ito yung horizontal? Bakit ito lang yung bakit ito lang yung initial condition natin for this case of voltage VI? Ay, shit. Saan na yan? Where is it? Bakit ito lang yung initial condition natin? At yung initial condition natin dahil, ayan na yung, dahil sa part na ito, dyan na nagkaroon ng, dyan ay na-store na energy doon sa capacitor mo. Okay? So pagdating dito sa point, magkakaroon na siya ng input. So magkakaroon na ng change dun sa energy ng capacitor. So kunwari itong problem na to, inusog mo yung kunwari ganun pa rin yung kunwari ganito pa rin. Inusog lang natin tong inusog lang natin tong axis natin. Ito pa rin yung initial condition, guys. Ito pa rin yung initial condition. Ito pa rin. Kasi dito siya galing from infinity. So, ayun lang yung in-store sa kanya. Okay? Ito pa rin yung input mo. Ito pa rin yung input mo. Ang problema mo nga lang dito is paano mo ilalagay yung equation mo, yung VI mo. So, yung VI, pag ganito yung case, that would be, ano yung kanina? K2 plus K3 T, no? So, syempre, iusog mo lang yung T. Kuwarit, ito ay T is equal to negative 5. So, iusog mo lang itong ano, T mo by some amount. Okay. Hindi ko na i-reveal. Kaya yun na yan. Ano ko ba yung, naasagot ko ba yung tanong mo? Ko alam kung nasagot ko yung tanong mo eh. Laging yung initial condition yung matagal nang na-store sa kanya. Anyway, let's go back and state method. State method, number 1, okay na. Yung Thevenin equivalent circuit. Number 2, yung tao natin is just RC. Number 3, ZIR. So, yung ZIR mo is yung initial things mo. Okay? So, ZIR, ano nilagay sa kanya? K1, di ba? K1. Tapos, i-dissipate mo. E raised to negative T over RC. Okay, nice. Okay. Next is yung sa part na nung input natin. Okay? So, ganyan yung input natin, di ba? K2, tapos may slope ka na K3. So, pwede natin i-breakdown to. Pwede natin siya i-breakdown into a step na K2, tapos ramp K3. Okay? Okay. Now, ang gusto natin, when we're working with this, gayahin natin yung kanina. Ano ba yun? ZSR natin, ang gusto natin gamitin ay yung derivative ng state variable mo. Okay? So, ginamit natin dito kanina is yung derivative ng state ng natin, which is IL. Yung sa inductors natin, current yung state niya, diba? State variable niya is yung current. So, gamitin natin yung derivative. Nun? Para mas madali, mas onti huhulaan mo. Okay? Kasi pag hindi naka-derivative, may mga extra terms tayo na weird. Okay? Wala dito sa VC natin, meron ka mga ganitong term na mahirap hulaan. So, ang gusto natin mga nasa in terms of these parts lang. So, yung derivative nito yung kukunin natin. Okay? Okay. So, yung derivative na to, yung related sa derivative niya would be, syempre, yung IC. Okay? IC equal to C dVC over dt. Okay? However, ang gusto natin, sabi ko nga kanina, mag-work on with voltages. Bakit tayo pumunta ng current? Bakit tayo pumunta ng current? So, pag current kasi may hirapan ka, so you have to go back to another voltage para rekta mo magagamit yung itong pinagsasabi ko dito na i-derivative mo or integrate mo, di ba? Okay? So, paano ba ito magiging tawag dito? Voltage. So, pwede mo siya multiplyan ng di ba? Yung VR natin, alam natin na IC times R siya. Okay, so this is nice. Okay. Gamitin natin itong equation na to para maging voltage na tong IC natin. Okay? So, anong point ko? Meron kang RC, DVC, okay? Or pwede na siya maging equal sa rectang e raised to negative t over tau, or integral ng dot 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 e raised to negative t over tau dt. Okay? Okay. Okay. So, yung sa VR1 natin, ito, pwede natin siya ilipat na agad. No? So, IC 1 R. So, RC times DVC 1 dt. So, RC times yung derivative nito, which is negative C, tapos K1. Okay. So, negative K1 siya. E raised to negative T over RC. Okay. So, next, kunin natin yung VR2, which is IC2R. Okay. Ngayon, hindi mo na kailangan dumaan dito. Hindi na natin kailangan hanapin yung VC. Okay? So, pwede na tayo rumekta dito. Pwede na tayo rumekta dito sa mga to. Okay. So, sa 2 natin, meron tayong step input na K2. So, sabi ko nga, as is lang yung mangyayari pag step. So, ito lang yung lalagay mo. And another one is R3. Tapos, IC3 times R. Ngayon, sa 3 naman, it's a ramp. So, I have to integrate from 0 to t. Tapos, derivative nung supply, d over dt. Supply ko times e raised to negative t over tau d t prime prime. Okay, and this is just K3. Tapos, e raised to negative t prime tau dt prime. And this is just 0 to t ng d. Ay, ano ba yun? Sabaw na. Okay? Okay, so with this, I have yung negative tau pa pala, no? Negative tau. Okay, from the integral. So this is actually equal to K3 tau na 1 minus e raised to negative t over tau. Okay? Okay. So now the solution for V are rekta na naman sa this. Sum mo lang yung tatlo. So we have K2 tapos minus K1, K2 minus K1 e raised to negative t over tau plus K3 RC 1 minus e raised to negative t over tau. Is this the same thing that we obtained earlier? K2 minus K1, dissipate, K3 RC, charge. Okay. So meron pang isang way to do yung ZSR and ZIR. Okay? Gagamit ka naman nung discharging and charging. Okay? So may isa pang way na kung gusto nyo, pwede nyo siyang by example, aralin. Pwede kayong mag-try ng mga different problems. Tapos, may ma-generalize kang way para itong mismong gagamitin. Ito yung mismong gagamitin. Okay? Kasi ang ginamit lang natin is yung idea na kailangan i-discharge lagi yung kung ano may malalagay sa kanya at every point in time. Okay, kaya tayo merong ganito. Tapos puro discharging tayo. Merong isang way na rerekta ka dito. Okay, rerekta ka dito, no? Imbis na gumamit ng puro discharging lang. Merong way na puro may discharging then may charging part. Okay, meron pang isang ganun. So, hindi na natin din dito. Pero again, di ba nakita nyo naman na slow and steady wins the race. Itong slow and steady, it gives you the right answer. Okay? So if you're confused with this as a state method na part, no worries, walang ano yan, walang bearing kung anong gagamitin mong method sa exam. Okay? Walang bearing yan. Kung gusto mong gamitin tong state method, okay, nice. Okay, again, sa state method, ang gusto mong gamitin yung mga derivative, no, na state variables. Kung meron kang inductor current, ang gusto mo yung voltage nun, no? Yung naka-derivative nun. Tapos ipa-pattern mo ngayon kung ano yung source mo. So luckily, doon sa una, kapag dinerivative mo yung IL, makukuha mo yung VL, di ba? Tapos voltage na siya, tapos voltage din yung source. Madaling magamit yung values na sources mo. Okay? Dito sa pangalawa, medyo nahirapan tayo kasi pag dinerivative mo yung VC, makukuha mo yung IC. Pero yung IC kasi current siya, tapos yung sources natin ay in terms of voltage. So hindi natin pwedeng gamitin yung rectang ganito bigla. Okay? Kasi ito ay in terms of voltage. Okay? Units nito ay voltage. Hindi mo siya pwedeng gamitin agad. So kailangan mo humanap ng relation kung saan gamit mo yung mga bagay-bagay. Okay? Okay. So, ayan. Any questions? So, next week, no? Mahabang discussions tayo. Magbibigay pala ako ng Probset tapos lahat na ng Probset ay ang deadline nila before finals. Okay? Okay, nasa sa inyo na kung gusto niyang gawin ba before third exam para maaral. Pero, ayan, probably yung third exam, sure na, no? Sure na may galing na may Probset level na tanong sa third exam. Okay, so malas yun na lang kung di nyo sinolve yung Probset tapos lumabas yung form niya sa exam. Okay, nakita niyo naman sa second exam na ito yung isang tanong, di ba? Ito yung isang tanong. Nagbago lang yung mga values ng resistors. Okay, naging ano sila, in general form sila. Okay, sige, hanggang anong topic po ang coverage ng third exam? Okay. Ideally, ang topic na kailangan natin ay hanggang resonance ng circuits. So, chapter 12 to 14. Okay, so ayun. Resonance. Pero kung di tayo mabot sa resonance, edi nice, di natin isama, syempre. Kung hindi maabutan. Okay, so kung may tanong pa sa Canvas na lang, time na tayo. 2:35 na. And again, kung may pupunta mamaya sa Ateneo, nice. Ay, naka-record pa pala.